Hey everybody, this is Larry. This is day 25th of the September Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think of this problem and in general. And yeah, especially Discord because people are very friendly in there. Yeah, so today I'm still in Spain, in the city of Bilbao. Yeah, flying out here, need to check out in about an hour or so again. So maybe this one we'll see how that goes. Yeah, let's get started. Happy Saturday, happy weekend. Hope y'all have a great week. Okay, today's problem is shortest path in a grid with obstacles, elimination. Okay, so you're given a grid, you can move up, down, left, right. Okay, in the minimum step the left corner to the lower right corner, given that you can eliminate at most k obstacles. Okay, let's look at the constraints. So the grid is 40 by 40 at most. What's k? K is at most 1600, I suppose. So okay, so my first inclination. Okay. Hmm. I, I was going to actually. I was thinking about a couple of ways, but yeah. So, hmm. Hmm. So first inclination is doing a breadth-first search, um, of course, but then we have to look at the case and the constraint. So you can do this thing. I call it like lifting up a dimension, basically creating a dimension to create a state, kind of similar to dynamic programming, so that you can use K, right? So that you can think about it as creating a dual graph or a equivalent graph maybe, where where for every node, every time you hit an obstacle, you go to an a graph of a different k. So that's basically the idea. But given that given that we have 1600 k, that means that it's going to be 1600 times 1600 square. That actually doesn't seem that slow, but it may at least be tricky. At least with respect to timing, unless this is a problem where the code is just bad, where you know, um, where we might be fast enough anyway. It's just that the constraints are very poorly, like representing the input. But let's see. Can we do this in a different way? I mean, you could eliminate half by doing like meet in the middle type thing, but that's still I guess that in theory that actually was it 1600 times 800. I think that should be actually be maybe something that I would consider doing, but maybe that's annoying to do. And in Python anyway. What is 1600? Actually, let's just do the 1600 square. Maybe that's not so bad. That's only 2.5 million. I think to be I think one thing I would say is that in other languages, I don't know why. I mean, it is what it is. In other languages, 1600 square, I wouldn't even think about it, and I would just do. But in Python, in Leetcode specifically, I always have some hesitancy um, because because the time limit is based off the sum of execution time, and as a result, the number of test cases they give you to test you will determine whether your code pass or not. So yeah, so that's kind of like a not great way of doing it, but that's how they do it. Okay, so let's try that m times n times k algorithm, and then we'll see how that goes. And actually, you can. Is it breadth-first search or dice draw? That's what I'm trying to think. Um, hmm. Well, no, I think breadth-first search should be good enough because you're still returning the minimum number of steps. As long as you're not doing anything really funky, it should be okay. Let me also think about it for a second. No, okay. You did. I'm just trying to think for a second whether you only need to visit each cell once, but now that because you can get to the same thing with a different K, then you may do that. Okay, so let's do it. So what is the also the other thing is that I think I was wrong about so originally I said that it may be m times k for for the time complexity in a rough well that's the size of the graph, right? In our second graph that we constructed, that's the size of the graph. So let's cross this out. This is actually the size of the graph. But is that the time constraints? Actually, now that I think about it, I don't know if I mean, way obviously, every state is not reachable, right? So it should be actually way faster than this. So we probably should be okay now that I think about it. I was just being, I guess, big old complexity hides some of the worst case analysis, where, or like, you sometimes you just do things pessimistically if you're not careful. But I think a lot of these states are not reachable. For example, if all of them are mines or whatever they have, obstacles, um, then you can get to the other side with 0k anyway. So most of the things will be not used. So then the question here is, what if we're given this maybe sparse graph, is it better to represent that as a three-dimensional array or a three-dimensional matrix, or like a set or something? This is kind of tricky, especially since sets. I know that in many cases I say sets are all of one and stuff like that, but effectively you can use it. But at many elements, it and it starts being not. So we'll see what happens. Um, we'll use this for now. And I use this in knowing that if this times out, then we have to do something else. Yeah. No, I want an actual thing. But yeah. And then now we set this of 0, 0, 0 equals 0. So, so our three dimensions will be, and you can actually still use dictionary in that way. So maybe it's not so bad if we are careful. We can convert this into a three-dimensional dictionary or something. So yeah, so it's not so bad. But what was I going to say? Oh yeah, this is x, y, and then k, right? That we used. So now this is just breadth first search. So let's get started on the breadth first search. Let's see. That's the state. You can write this. I honestly also sometimes I write these from experience. So sometimes I write things a little differently. And this time I'm going to write it this way, I suppose. I don't know. But sometimes I also put the distance into it, but I guess it doesn't really matter for this particular one, because you don't need to sort by anything. It's when you get there first, right? So yeah. Okay. Let's see. So then now we do the directions. It's I'm just gonna double check that's the 4 direction, not 8 direction. I always some grid problems are 4 up, down, left, right. Sometimes 8, which is the whole circle. So yeah, let's see. Yeah, I didn't do most yet. Okay, I think it's alright. Okay, so it's this, and well, we haven't seen it yet because it's by first search. So have to do new k, which we have done yet. Okay, so I think this would be good enough in theory. We'll do another thing. We have to do one more check actually. We have to do new k is less than or equal to k and this stuff. Also, we have to use, let's just say ops. It's really weird. Okay, maybe not. Maybe I'm just being confusing. Tired. Okay, so then new k is equal to k plus. I guess in this case, actually, this is very easy. So basically, you're stepping on a mine. You get it. You used up one of the k's. And in this case, it's only 1, 0, so you don't have to do anything differently. Let me shoot it. Okay, 1 is an obstacle. Okay. From here, we can also do nx is equal to rows minus 1 and ny is equal to columns minus 1. Return d plus 1. And then that's it. Maybe we can do it impossible, which is, I don't know if it's negative 1. Okay, it is negative 1. Let's give it a go. I don't know why they make it so annoying. Okay, one time okay, yeah. Oh yeah, that makes sense. Are you because basically okay. I was trying to put in one statement, but we have to do this. Okay, so this looks good. Let me take a quick look. Yeah, I mean, I think the only thing that I worry about is, well, two things. Type 1 is just typo, so I mean, it is what it is. And then 2 is just time limited, but I think we're okay, maybe. We'll see. Let's give it a submit. Unless, or like we get a time limit because of a typo. Oh no, wrong answer. Oh, okay. This is such a silly thing, though. I mean, okay. Yeah, okay, fine. Okay, fine. Yeah. What is silly? I mean, it is correct, but for some reason I didn't look at constraints enough. I thought that would not be possible. I think I'm just a little bit pushed a little bit. Okay, fine. Okay, cool. Yeah. So the worst case is going to be the size of the graph, even though, like we said, it's not many of those are not reachable. I think you can do a lot of math about more precise, but at least half of them are not going to be reachable. So yeah, so it's gonna be, but that's the complexity because it's a breadth of search, so you have to look at the entire graph, and the entire graph is now m times n times k, right? And in terms of space, that's also kind of the upper bound, but because we put everything in in the queue and the distance, but like I said, most of them are not reachable, which is why we use a set here or a dictionary here, so that use a dictionary here so that we don't have to pay the cost of all the memory. I don't know if it's good, but yeah. I think that's all I have for this one. I have to finish packing and check out. So anyway, stay good, stay healthy, to good mental health. I'll see you later. Have a great weekend. Bye bye.